In today's lesson, we are going to be looking at common factoring. So this is kind of a continuation of our previous lesson on expanding, just kind of the opposite side of it. Right, so what is factoring? Right, factoring a polynomial is the opposite of expanding a polynomial. So if we think of what we looked at yesterday when we were expanding, right, if I want to multiply x into 4x plus 5, I can expand that or multiply and get 4x squared plus 5x. Now, factoring, which is a new concept that we're learning this year, that is going in the other direction. That is basically taking our product or taking our answer and rewriting it as two factors or two terms that are being multiplied to each other. So it's a little bit different from what we've done. It's something you haven't done before, but it's just basically kind of going in the opposite direction or the opposite process of what we were doing. So we can use algebra tiles to help factor, right? So if we have our answer now of 2x plus 4, right, that is now going to be the rectangular area on the inside, and we have to figure out, okay, what dimensions make up the length and width of this, right? So if we bring up our tiles here, I'm going to have 2x, so x and 2x. And our goal is to make some sort of rectangle that makes sense, right? So it can't be just something like that. That's not really a rectangle, right? That's a rectangle. Right now it's 2x and 2, but I want 2x and 4. So now that I have this, I need to come up with the dimensions. So what would basically give me, or what times what I could think of would give me this long rectangle? Well, it does have a width of 1, and so does this bottom one. It also has a width of 1, and it matches up with these two spots on the end. And on the top, I would have to have a long rectangle and then two small squares. So now when I look at this, I'm going to look on the outside and think, okay, what is each outside? So let me take this answer. We'll screenshot it. We'll put it onto our page here. And we'll talk about it, right? So if we look at our page now, this is our answer, right? Before we were counting the inside. We want to know when I multiply the two edges, what do I get on the inside? Now it's the opposite. We're going to be looking at these two parts. And each one of these is going to represent a term or something that we're multiplying, right? One of my factors. So the first one, we'll look at the top one. This will be one bracket. And if I look at it, I have an x plus 2. And on the other side, that's going to be my other bracket. And in that one, I have just 2. So this would be the same thing as saying, or if I factor 2x plus 4, it's the same thing as saying 2 times x plus 2. So it's the same thing. Now we're just rewriting it as a factor rather than the product. So basically we're saying 2 times x plus 2 will give us 2x plus 4. So we're just rewriting it in a different way. I can do the same thing with the next two. So let's go back to our tiles. And we want to factor or come up with two factors or two things that when I multiply them, I get x squared plus 4. So again, I'm going to put on the inside, I have an x squared, and now we need a plus 4x. So I could say, okay, 1, 2, 3, 4. And that would work. I've made a rectangle on the inside. Right now I can use this to help me figure out the outside edges. So on the outside, it would have to be a long rectangle to have that same width. On the other side, I would need to have a horizontal rectangle, and then I would need to have 1, 2, 3, 4. So there is my factoring represented as algebra tiles. So let's copy and paste this into our solution. And again, if we look on the edges, that is going to be our two brackets. I am going to put the single one on first. So x will come first, followed by x plus 4. Right? Because again, the rectangles are x, the squares are 1, and the big squares are x squares. So this works out to, or when I factor it, 4x, or x times x plus 4. Last example, 2x squared minus 2. So I'm going to put this on the inside. I have 2x squareds and then we're going to have a minus 2. So it doesn't really help me out too much. I can't really make a rectangle like this. So this one is a little bit more challenging, right? We do know that because we have these, we do have to have an x on the outside and 2 x's up top. Now the challenging part comes in on what would I have to have, right, to make this work. I can't really make a rectangle or anything with this. Right? So this one is a little bit more challenging because we're trying to make a rectangle with the inside. I could have, well, I'd have to have something on the outside. So I'd have to have like a 1 here, because that would give me x's. Right? I would have to have some sort of 1 here. So maybe we have 2 1s. No, but again, it doesn't really work. So this one is a little bit more challenging, a little bit harder to do. So not every example is easy to go through and rewrite the insides, right? Especially if we have some shapes that don't really kind of work out, right? So we're going to leave this one for a second because it doesn't really help, or this method doesn't really help in this example. So we'll come back to this one, but we will say that the answer should be 2 times x squared minus 1. Right? So a little bit harder to get. We wouldn't really have thought of that based on what we had done previously. So let's look at another way that we can try to go through and factor rather than just using algebra tiles. It's helpful to get an idea of how it works, but it can be difficult in some cases. So we're going to be using or referring to what we call the greatest common factor. And the greatest common factor is the highest value that divides into 2 or more terms. Right? So now the highest value could be a number and or a variable. So the greatest common factor could be a number. It could also be a variable, right? So it doesn't necessarily have to just be a value. So we're going to look at a couple of just values though, and we want to think about what is the greatest common factor for 10 and 20. Again, our definition is the highest value that divides into the 2 or more terms. So what is the highest value that divides into both 10 and 20? Right? You could break down each number and think, okay, what numbers multiply to give me 10? Well, I have 1 and 10, 2 and 5, and that's it. For 20, I have 1 and 20, 2 and 10, 4 and 5, and no other values. So now I have to look at these and say, okay, what is the highest factor? And in this case, it would be 10. So the greatest common factor for this one is 10. Now you don't have to go through and break each number down into its factors if you understand what numbers multiply to give us 10 and 20, right? If you don't need to break it down like this if you don't want to. But again, it can be helpful if you're stuck. 4 and 16. Again, same idea. If you want to break it apart, 4, we have 1 and 4, and then 2 and 2. For 16, we have 1 and 16, 2 and 8, 4 and 4, and then that's it. We could repeat and say 8 and 2. That's the same thing. If I look for my greatest common factor, the greatest number that comes up in both is 4. So my greatest common factor is 4. For 3 and 5, 1 times 3, that's it. For 5, 1 times 5, that's it. So in this case, my greatest common factor is 1. Right? Or you could say there isn't really a greatest common factor because everything can be divided by 1. We'll learn that it's not when the greatest common factor is 1, you can't really do much more to it. Because if I take out or divide things by 1, it's not going to change anything. So when we're common factoring, there's things we have to, or some steps we have to kind of look at. Right? So the first thing we want to do is look at the coefficients, or basically we want to look at the numbers. And we have to think, is there a number that goes into all the terms, right? That's part of what we're doing when we're looking for the greatest common factor. We then have to look at the variables. We have to look at the letters. So our greatest common factor might be just a value. It might also be a variable, or it might be both. So we do have to look at the variables, and we have to think, are there any letters present in all of the terms? From there, right, if there is a letter that is present in each term, we have to look for what is the lowest degree on the common variable. Right? And when we talk about the lowest degree, we're talking about the lowest exponent. Then we have to determine what the common factor had to be multiplied by to result in each term. So those are the steps, right? And we're going to go through and we're going to use those steps to help us factor. So we're going to start off fairly easy. So in the first one, we have 3x plus 6. So I have two terms here. I want to look at the coefficients or the numbers first and think about what number divides into both 3 and 6. Well, the number that divides into both 3 and 6 is 3. So right now, my greatest common factor is 3. Is there a letter or a variable that is common between both these two terms? In this case, no, because one has an x and the other does not. So that means I don't have to go through and look at the further steps at the highest exponent, such and such, right? I just know my greatest common factor is 3. So now I have to think, okay, 3 times what is going to give me each of these terms, right? My greatest common factor is 3. That's one of the values that I'm multiplying to get 3x plus 6. So different ways you can think of it. You can think of it, okay, 3 times what gives me 3x. In this case, it would be x. Or you could say, okay, if I know that 3 is my common factor or greatest common factor, I can take 3x, divide it by 3, and the leftover, or whatever remains, has to be the first term in the bracket. In this case, 3x divided by 3 is just x. So that is our first term. For the second one, the plus 6, what 3 times what gives me 6? Or I could think of, okay, 6 divided by 3 equals what? It equals 2. So that means plus 2 is in my second bracket, or second term in the bracket. Now, if you're unsure if you got the right answer, you can expand. Because if I expand, that should bring me back to where we started. And 3 times x is 3x, 3 times 2 is 6, so I know I did the right factoring. For the next one, 8x squared minus 7x, again, we're going to look for our greatest common factor. We're first going to look at the coefficients, the numbers. Is there a number that is common, or a factor that is common between 8 and 7? There is not. Right, other than 1, but that doesn't really change anything, so I'm not going to worry about that. Then I have to look at the variables. Is there a letter that is common between both 8x squared and negative 7x? In this case, yes, there is an x. So there, I am going to be taking an x out. I do have to consider what is the most amount of x's that I can take out. In this case, right, I have to look at the exponent and I have to take the smallest exponent. In this case, we have an exponent 2 and an invisible 1. So that means that the greatest common factor, or the exponent on this x squared that I can take, or this x that I can take out, is just going to be x to the power of 1. So that means my greatest common factor is just x. So that is going to be the first term on the outside. Now I need to figure out what is going to go into my brackets, right? So you could think about x times what gives me 8x squared, or you can take that term 8x squared, divide it by my greatest common factor, which is x, and see what we get left over. We'll be left over with an 8, the x and the x squared cancel each other out, or cancel out partially, so there's going to be 1x left over, or 8x. If I look at negative 7x divided by x, the x's in this one cancel out, and I'm left with negative 7. So that means 8x minus 7 is what is in my bracket. And now these are my two factors. So x times 8x minus 7 gives us 8x squared minus 7x. C, again, similar idea. Right, let's look at the coefficients for the greatest common factor. In this case, there is a the coefficients is 25 and 15, so I can factor out a value of 5. 5 is the greatest factor that goes into both 25 and 15. Both terms do have an x as well, so I can take out a factor of x, and because they both have exponents, I want to look for the smallest exponent in this case, which is 4, and that is what I can take out, the most x's I can take out. So that means 5x to the power of 4 is my greatest common factor. So that's going to go outside the brackets. On the inside is going to be whatever I have to multiply 5x by 4, or 5x to the power of 4, to get these two terms. Again, if it helps, you can think of it the other way. 25x to the power of 6 divided by 5x to the power of 4. And let's think about what's left over. Well, the 25 and the 5 cancel each other out. We're left with 5 on top. The 4 and the 6 cancel each other out, dividing exponents, so that means I'm left over with 2. So I have 5x squared. For the second term, the 15x to the power of 4, I have to think about 5x times what gives me that, or 5x to the power of 4 gives me that, right? Or I can divide. Again, whichever way you choose is up to you. So 15 divided by 5, they cancel out. I'm left with 3. 5 or x to the power of 4 and x to the power of 4 cancel out completely. So I'm left with just 3. That means that my two terms inside the bracket are going to be 5x squared and then plus 3. Again, you don't need to show this step if you're comfortable saying, okay, well, 5x to the power of 4 times what gives me 25x to the power of 6. If you're comfortable just doing that in your head and putting down the answer inside the bracket, that's fine as well. If you're not, then maybe do the division to think about what what do I have to multiply the greatest common factor by to get my terms. And again, if you're ever unsure if you got the right answer, just expand and you should end up back at your starting question. Now, in some cases, right, the greatest common factor may not be a singular term, right? If I look at these two terms, and I'll highlight the two terms, right, because remember, the terms are separated by addition or subtraction. So my two terms are products, the product of 2x times y plus 1 and the product of 7t times y plus 1. If I look at these two terms, is there anything that's common between them? And in this case, there is, and that's my greatest common factor in this case is going to be the whole bracket of y plus 1. So I can take out the bracket y plus 1, and the leftovers, the 7t and the 2x, are going to make up my second bracket. So 2x plus 7t. So in some cases, we might be able to common factor an entire bracket out. So for example, in the next one, again, if I highlight my two terms, just so we have an idea of what we're working with. I have 2x times x minus 3, and then subtracting 5 times x minus 3. In this case, the whole bracket, or the greatest common factor in this case, is x minus 3. So I can take out that whole bracket, and the leftovers, or whatever's left over or remaining, makes up my other bracket. So we've looked at common factoring. We've looked at common factoring if it's a bracket. Right? We're going to factor by grouping. So if we have more than 3 terms, we can actually group terms together and factor them that way. So we're going to look here and we're going to see if there's anything, or we're going to try to factor the following in 2 different ways. So by factoring by grouping, I'm going to group my 2 terms together, these 2 terms, and we'll group these 2 terms together. And we're going to factor or common factor these 2. So if I look at common factoring these, I end up with, okay, well, what's common between both of them? Well, I can factor in this first one. The greatest common factor here would be a, because a is common between the both. And the second one, the greatest common factor would be 2, because they both, there's a factor of 2 in both for the coefficients. So that means for the first term, I have a times x plus y plus 2 x plus y. However, by factoring there, I still have 2 terms. Similar to our last example. And by looking at these ones, I have 2 brackets that are the same, x plus y, so I can actually take a greatest common factor for this one of x plus y out and be left with a plus 2, the remainders, or whatever's left over. So that's one method. Another method might be to group different pairs, or to group the a different set of, or a different pair together. So instead of ax plus ay, I might have 2x plus ax plus 2y plus ay. So because it is all addition, we can rearrange this. If we had subtraction, we'd have to make sure that we carry the subtraction with us. But because it's addition, I can just kind of move the different terms around. I'm still going to common or factor by grouping. So I'm going to look at the first 2 terms. I'm going to look at the last 2 terms, or basically 2 pairs. And if I look at the first one, there's a common factor, or greatest common factor of x. X is the only thing that's common between those 2. Same thing in the second one. Y is the only thing common between those 2 terms. And if I common factor the first 2 and take out that x, I'm left with 2 plus a. If I take out y in the second one, I'm left with 2 plus a. Again, still 2 terms, kind of like the last example, but there is a common factor in these 2 terms. Again, in these 2 terms, the greatest common factor is the bracket itself, 2 plus a. So I can take 2 plus a out, and I'm left with x plus y. And what do we notice about these 2 answers? Well, they're the same. Right? X plus y times a plus 2 is the same as 2 plus a times x plus y. So when we factor by grouping, sometimes it doesn't matter which pair we put together. We could still get the same factored answer. Now, in some cases, we have to be a little bit mindful, right? Because if we were to kind of pair it up as ay plus 2x together and ax plus 2y together and said, oh, well, what's common between ay plus 2x? There's nothing really common. There's not a common factor between those two, right? So when we're factoring by grouping, we might have to be a little bit mindful about how we arrange things or what we group together when we factor. Right, so again, a new concept. So again, make sure you are practicing this. I would definitely say knowing your times tables will help. So if you can get a multiplication table or anything like that, that will be very helpful when going through these types of questions. Just because it helps you see all the different factors, or you say what numbers go into 10. I can find everywhere on a multiplication table where we have 10 and then see what the two factors are that make it. So again, factoring is the opposite of expanding, which we learned yesterday and we looked at yesterday and you've looked at in the past. So again, with this factoring, make sure you are practicing because this will be important and we will be looking at many different types of factoring later in this unit.